I am very proud of to introduce the paper Storage Performance Analysis of Cloud Computing Server by Querying System. Cloud computing is a further development of distributed computing and parallel processing and grid computing and quickly become a hotspot in industry and academic research. QS performance metrics typically includes response time, blocking probability, and probability of immediately service. If the cloud computing center is shown to be a random service system. Each computing service, such as a network server, database server, can be named as the service platform to build a electronic service system. The QS performance metrics can be discussed by the research method of querying theory. The performance indicators of QS are usually defined in form of SLA. SLA is a conclusive agreement between customer and the service provider, including service availability, performance, and data protection and security. Accurate prediction of customer service needs can enable service provider to avoid over providing resources in order to satisfy customer request is a variable load. It's difficult to satisfy and achieve optimal utilization and resources by dynamical configuration running computing resources. However, we can analyze the service performance by modeling the cloud computing center and obtain the probability distribution of request response time and other performance indicators and discuss the features that affect the performance of cloud computing center. In a querying system, service station will adopt variables strategy and of customer reception in some time, and the service in temporary interrupt time usually is a random variable. It's referred to the location. In 2015, we presented a querying system part of the service station based on anonymous multiple location and the service processing of cloud computing center corresponding querying system by the analysis of the corresponding querying model to investigate the performance index and optimize allocation of resources in cloud computing. The user send tasks to the cloud computing center and a suitable computing node provides the service. After service complete, the task will leave. Computing node contains different computer resources such as network server, database server. The assuming of a computing node corresponds to querying service of one system. The user sends the corresponding querying system task arrival process Service completes the service process corresponding to the querying system. The process of resource allocation in cloud computing server can correspond to a querying mode. Then we can assume that the following steps. One is a time between arrival charts is a time serial. The distribution is a generic distribution, and the parameter is p. The second one is in the system there one server, and the time of service is variable x. Okay, we can say the distribution is this concrete distribution is um, the second one is the arrived time and the service time are independent. The variable NN is the number of customers in the service system that is query length of the querying system. We can supporting um, such as the traffic indices of service system and so on. Okay, the NN represents the task number of the cloud computing system, like the time of the distribution of the steady querying length, just as limit pg, just as limit p. Okay, we can get the true feature when row is more than one, and such as more than one, such as two, three, and so on. Okay, the second is the row is less than one. Okay, we can get the other distribution. Okay, we can get the following feature to satisfy SLA or the clouding computing the features. One is the probability of immediate service. If a customer arrives and the experience of the station service is free, customer service can be accepted immediately without waiting. Probability of this happening calls immediately service availability. Mm, by the study querying length distribution is immediately service probability, we can got the following P0. The second is the time of server idle. The server idle is the time when the system has just turn the empty until time when a customer arrives. We can supporting the variable as system idle. Okay, we can get the um, distribution as following. The server busy period is the time when system has a customer arrive until the time when the last customer leaves. Okay, we can express by a variable b. Average time of continuous work of cloud computing service is the exception of b, and its value as follows. Okay, other factors we can see in the paper. 那么 service performance metrics by JG1 with location. Users in the cloud computing task for service in suitable computing node. After service is completed, customer leaves. Computing node contains different computing resources such as network server, database server. Assuming of a computing node corresponding to querying service of one system, the corresponding querying system has arrive process, which which is the user, which is the user send and the service process corresponding to querying system, which user service complete can be process of resource allocated in cloud computing corresponding to a querying mode. The real cloud computing services generate part of server vocation live for anonymous data and in the absence of the user can be repeated live. So the process of resource allocation in cloud computing center may correspond to a part of service station anonymous multiple vocation querying system J JG1. Okay, the system models discussed in this paper the following specified location places. One is the time of task arrived in trouble is time serial. Distribution is a geometric distribution with parameter p. The second one is in the system there is one service station and the time of service variable as the distribution of that is discrete distribution. Customer service according to FCFS service rules. The third one is the server platform not only can complete a customer service system and meet in the customer rating, but also can continue for the next customer service. Then we can get mm, time of service busy, the first one, the variable B is a server busy period, and the probability generating function of variable B is such as this AB. The second one is the average number of clients waiting for service on the server according to the definition of expectation average time of continuous work of cloud computing server is the average querying length AUN of querying system, such as the number of requests for querying. Okay, we can get the AN such as this. Other factor we can see in the paper number. mm, okay, the fifth model analysis and the service performance index, assuming that the system simulation time in minutes. The arrival interval of task-based geometric distribution. The service completion time based the discrete distribution. We can analysis the service performance index of cloud computing system. The first one is service performance index with no vocation. The immediately service probability as follows: P0. The second one is expectation of service of server busy period is AB. The third one is the steady distribution of querying task PG, as in the table 1. We can see the steady distribution of querying task. The second one is service performance index with vocation. Okay, we can when P new and N N0, we discuss the standard distribution of requiring tasks, such as Fig 1, the, the standard distribution of querying tasks. By the standard distribution, we can calculate the average time of querying tasks in table 2. The third one is optimizing concurrent number of cloud computing. Concurrent number of the cloud computing is not enough to be more than the mean. For example, when P the steady distribution of querying tasks in the table 5. In this system, the average number of querying tasks is 10667. So the probability of the concurrent number is not enough, which is 37 or 3% if a concurrent number is a mean of querying tasks. For the probability of concurrent is enough, which will be greater in 99%. We must get a concurrent number which is more than 6. That's all. Thank you very much.